Hello everybody. Today inshallah we'll be covering one tool that is very important whenever we study lean manufacturing. This tool is called value stream map. In value stream map we try to draw a graph or a map or a figure that covers all the procedures that take place within a process. In order to illustrate how important this topic is, you can have a look here at the person who developed this presentation. He's the chairman and chief executive office of Boeing Company. This presentation is about the value stream. And he says that whenever there is a product for a customer, then there is a value stream. Whenever we're producing any product or a service to a customer, then we're doing processes. When we're doing processes, these processes can be classified as value-adding activities or a non-value adding activity. So if you draw them, this is called the value stream. So value stream map is a graphic representation of the actual steps taken place in a system. However, there is a big challenge. The challenge lies in seeing it. Sometimes the companies are not able to identify the actual stream or the actual value stream within a company. So today, inshallah, we'll be covering that part. And here is a big figure, another big figure here. He's the chairman and chief executive officer of Walmart in the US, one of the biggest store companies, supermarkets, retailers in the US. He says that there is only one boss. This boss is the customer. The customer is the only boss in an organization, and he can fire everybody in the company. He can fire everyone simply from the chairman on down, everybody, simply by spending his money somewhere else. So if the customer is not actually satisfied, he's going to spend his money in buying products from other companies, not from you. So when he does that, you lose business. When you lose business, you lose money. When you lose money, you fire, or everybody can be fired from a company. So back to the definition of lean manufacturing. What's meant by lean manufacturing? When we say lean manufacturing, the meaning is it's a relentless elimination of waste. We're keeping searching on every specific process in a system. And then we ask ourselves, is the customer going to consider every specific process in a system as something that is adding value to him or not? Then anything that doesn't add value is considered a waste. And waste is simply you're consuming resources and you're not improving the process. And here's the definition of waste. Waste is using resources. You're consuming a lot of resources, money, effort, raw material, time, without adding value. And we discussed the value here, as we discussed before. It's what the customers see or expect. So if the customer is not expecting that, or not appreciating what you're offering, or not appreciating a certain step, then it's a waste. It's a complete waste. If you have the customer to pay for a process and then he gets nothing from the process, it's a waste. When we store the product in a warehouse, then we need to pay for that. So we're consuming resources. But for the customer, he gains nothing. So this is a waste for the customer. Unfortunately, as we will see today, waste is all around us. We will see today that most of the processes are actually waste. But it can be very hard to see. Despite that we have a lot of wastes, most of the companies think that we don't have any waste. So today we will learn a method. By that method, we will try to quantify the percentage of the wastes that you have. So value stream map is a process or a tool. The tool we're covering today is called the value stream map. In that value stream map, we're drawing what actually happens in a process or in a company. So when we draw these processes, we can have a look whether each process is adding value or a non-value adding activity. So value stream map is a value stream is the entire set of activities running from raw materials to finished product for a specific product or product family. For example, from placing an order to buying the material, then storing the raw material, producing the product, saving the product, storing the product, delivering the product. If you can draw something like that in the way that we are going to explain today, this is called the value stream map. In a typical enterprise, value streams can intersect with each other value streams, branch apart or Y together. There are some misconceptions when we talk with the students about their understanding of the value stream map. They think that each company has just one single value stream map. That's wrong. As written here, it's for a specific product or a product family. If you're producing one product, two products, three products, you can draw a value stream map for each of them. But when you're producing a lot of products, it's very difficult to draw a huge number of value stream maps. So instead of drawing different value stream maps to different products, we group similar products together. When we group these similar products, we can get what's called the product family. So by saying product family, it means some products that are very similar can be combined, and when you draw their value stream map, you can draw just one value stream map for them because they are very similar. Suppose that you're producing a chair here that has either blue color or black color. So basically it's the same step, except that we get different raw material for the colors or the paints. So we can draw just one value stream map for all of them. However, if you're producing a part that that is used in different products, for example, you're producing some textile, and then it's cut into two pieces, and one of them will do something here, and we can produce another product here. This is called Y. It's something like that. It's branching apart. Or you can have two inputs, and from these two inputs you can produce one. So this is a value stream map for one product, and this is value stream map for the second product, and then they meet together. So they can meet together, branch apart, or intersect together. So what you should understand, or you should be able to know so far, that value stream map is just a figure that represents all the steps that are taken to produce a certain product within a certain company. So the question is, why do we do that? And the second question, what are the components within that map? To answer the first question, we need to know that value stream maps are powerful visual tools. So this is something visual. By saying visual, it means we translated the process and the description of the process or the job description into something visual that's very easy to understand, then analysis. So when we do that, it will help us see waste. We will see every process, and then we can classify each process whether this process is a value-adding activity process or a non-value-adding activity process. Moreover, you can use this value stream map to understand the flow of material and information. How does the material flow inside your supply chain? How does the information flow inside your supply chain? This is especially very powerful for illustrating the wastes of overproduction, idle material transportation. In other words, overproduction, when you produce something like that here, and we find that we produce 100 and we consume 10. This is an overproduction case. It will be very obvious from our chart. Or if you store a lot of material here before a machine, this is idle material. We're not doing anything with the material until there is a production. If we move from one part to another part, all of this will be very obvious from constructing a value stream map. So value stream maps show all actions required to deliver a product. One of the common misconceptions here is that the students think from the name of value stream map that we need to draw things that only add value to the customer. And this is the wrong concept. What we do is we draw every process and then we classify later, then this is a value adding activity, this is not a value adding activity, this is value adding activity, this is value adding activity, this is not a value adding activity. So when we draw value adding activities as well as non-value adding activities. So make sure that you draw the current status as is, whether it includes value adding activity only or non-value adding activity as well. Do we get more benefits or other benefits from the value stream map? Yes, we can get other benefits, such as it provides a big picture perspective that helps focus on improving the whole process, not just optimizing bits and pieces. For example, let's say that we're producing 10 items, and then we focus on this process and we improve this process to be 12 items per hour. While the value stream map, or not the value stream map, the supply chain produces 10 at the first member and 10 at the second and the third member. So whenever you improve this one, the entire supply chain doesn't get any benefit from this optimization. So this is called the local optimization. It's an optimization for the department or for this member of the supply chain, but it doesn't add anything to the entire supply chain. So this is not a good investment. So when we draw the value stream map, we can get some information about things like that. Shows the linkage between the information flow and the material flow. Sometimes we don't know who's the source of the information, who's initiating the order, who's delaying the order. How does the information flow? How it is related to the manufacturing itself or the production itself. So this can be shown in the value stream map. helps to see across the functional boundaries over which a product's value stream flows. So for example here, instead of focusing on one function or one department, we focus on the process from the initial order until the finish or the delivery of the product. Sometimes the production occurs across different entities of the supply chain. It covers all of them. Other uses for the value stream map include to help understand how your business actually works. You don't understand the current process if you can't draw it. And there was a scholar who said, his name is Deming, I think. He said, draw a flowchart for anything you're doing. Until you do that, you don't really understand what you're doing. In other words, if you ask somebody, what are the steps you need to take in order to renew the vehicle license? The steps will be go to the license agent, do the inspection, pay the tickets, and get the new one. However, if you go and see what's actually happening, you need to go upstairs, downstairs, outside, inside again, then outside once a third time, and then go to another location and make a photocopy and another make it. So it's a totally different story. You don't really understand this story until you draw something like that. I arrived here at 8 o'clock and then we moved here at 8:30, then we get back at 8:45, then we do something here or did something here at 9. Then so until you draw something, you don't really understand all the details of the system. So it helps here. Number 2, it's a tool for establishing a vision and implementation plan for a new business or a product line. When we're initiating a new product or implementing a new plan, it's better that this is associated with a value stream map. It's also a visual tool and common language. So instead of having different languages, different names, different words, we have common language and common tool for talking to others about your manufacturing process, especially inside the same company. So instead of having different names because we're different plants, we have just one name, one value stream map. So we understand what's going on everywhere. When we say we're doing procurement at a certain step, we know what's meant by this. So how do we do the value stream map and how do we improve that? In order to know what we do, first we need to construct a product family. The meaning of a product family. Imagine, or let's say that we have 100,000 products. We can't afford drawing value stream maps to 100,000 times for 100,000 products. So instead of that, we will group them into product families that are very similar. So instead of having 100,000 products, different types of products, we can have, for example, 50 families. For example, air conditioners. We can say that we have commercial and business sector. And in the commercial, we can have split units and wind units. These are called families. So we have product families now. So instead of drawing a value stream map for each product within the split units, we can have one for all the products that are producing or that are providing air conditioning, split air conditioning, because they are very similar. So the first step is to classify the products. Instead of having a large number of products here, we say that these are equivalent to this small number of groups. So we need to draw one for each one of these groups. Each group is represented by one chart. Then we need to understand how the actual processes are taking place. So we draw something called current state drawing. So basically we're following what happens and takes place on the actual site, on the real world, in the real world. So what we do is we follow the product and see what happens in the floor of the plant, and then we classify each process in this drawing, whether this process is a value-adding activity or a non-value-adding activity. So by this, we understand how the value currently flows. This is the as-is situation. This is what actually happens in the real life of the case study. Then what we do is we have a look at all the steps that are a non-value-adding activity from this one. So from the current status, we look for the non-value adding activities. Here is one, here is another one. We try to remove them. When we try to remove them, we reach a new situation. For example, let's say that we're storing 1,000 items, while the maximum number of orders that we can receive is 500. So one of the possible solutions is to have just 500 instead of 1,000 items. So this is a new situation or a new future state. We want in the future, we want the status or the current practice to hold only 500 instead of 1,000. This is an improvement. So this is the future status. Then we implement this one and we assess and measure the performance. So one question would be, why do we keep 500? Why don't we keep 250? So once again, we consider the case of the 500 as the current new status, the new current status. And in this one, we try to improve it. So instead of having 500 items, we can have just 250 items. So this is a new future status. And we keep repeating. So we have a current status. We improve that current status. We reach a new future status. Then we measure the performance of the future status. And by time this future status becomes the current status. And we repeat again and again and again. So as I told you before, the very first step is to form the value stream, to form the product family. For example, let's suppose that we have here 6 processes. So this is department number 1, 2, 3, 4, 5, and 6. And we have 6 products. It could have been 7, 8, 9. They don't have to be equal values. And we write the names of the products. So product A requires processing in 1, 2, 3, 5, and 6. B requires processing in 1, 2, 3, 4, 5, and 6. Product C requires processing in 1, 2, 3, 5, and 6. E and D require processing at 2, 3, and 4. So from the current situation this is what actually happens in the real life, we can say that we can mix D and E as one family. Because as you can see here, all the products within E and D has to follow or have to follow or have to visit department 2, 3, and 4. Similar to this, A is exactly like C. We can say then we can have A and C as one family, and we can have B as another family. Or if this is a minor process, this is the difference between B from one side and A and C from the other side. So we can say A and C are considered as one family, while B is considered another family. Or we can say that we have A, B, C as one family. So what is the importance of what I just told you? The importance is, instead of having 6 outline value stream maps, in other words, we draw one for A, one another for B, C, D, E, F. The new classification is we draw one for E and D as one instead of 2, draw another one for A and C, and then draw one for B and one for F. So these are 4 instead of 6. And when you consider A, B, C as one unit, so you don't need to draw it here. So it ends as A, B, and C are together as one product, one family. This is the second family, and this is the third family. So we have now 3 value stream maps. In other words, you reduced the effort needed to analyze the process into the half. Instead of having 6 value stream maps, you can just draw 3 value stream maps. So to sum up what we have been discussing so far, the point of value stream mapping is not the map. In other words, it's not the objective of the current process to draw a map. No. The main objective is we want to understand the actual process, including the flow of information, flow of raw material, and classification of the processes as wastes or non-wastes. So we need to understand the current practice. We need to understand the current flow. We need to understand the current processes, the current value-adding processes. Now, when you understand the current situation, you can identify where is the waste. So the next step is then use that understanding and insight to improve your process. So when you understand the current process, we can identify where the defects or the wastes are, and then you improve them, and then you get a better implemented future states. That's the main objective. In other words, understand the current situation, improve the current situation, implement the better situation for the future. That's what we need to do here. So the first step is to draw the current state. So the current state map, once again, it's a picture drawn with pencil and paper. So we draw something on a pencil while observing the process on the factory floor. So we don't rely on whatever is told to us. We need to go and see by ourselves. That's what we called before as Gemba. So we need to observe the process on the floor and then we need to write it and then transform it into a picture, a graph, a figure that shows how material and information flows in the system. When we do that, we're creating a baseline for future improvement to be measured against. When we do that, we know what is the current status. It clarifies understanding of how the current production system actually operates. So now you understand what is going on in your company. And when you improve something, how it will affect the future. Now let's have a look at a detailed value stream map. It all starts with here, the customer. What does the customer want? So we start by, as you can see here, it's a graph, a picture. It uses some symbols that we will explain later. But for now, this represents a customer. In that customer, we write here anything and every information about the order. How many is ordered from each type? Do I need them weekly or monthly? And then there are two parts in that graph. Have a look at the first part and the below part. What's the difference? As you see, if you pay enough attention, the lower part consists of the production process. What actually happens? So this is concerned with the material flow within the system. So what's below is actually material flow. While for the above part, what we see is it's a flow of information. So we divide here the value stream map into two parts. One of them is concerned with transfer of data or flow of data, this part, and the second part below is concerned with how the process takes place within your company. We will be explaining on a production process, and then later we will identify what the difference between this one and what the differences between this one and the service are. Now, if you have a look at the production process, you will see that this is a process, and then we have some finished product. It's not actually totally finished product. It's products or raw materials that have undergone just the first production process. Fabric cut in our case here. So this is a cut fabric. So we have some stored item as cut fabric. And then we sew them here, sewing. So here we have some fabrics that are sewed. In other words, between every step, there may be some sort of work in process inventory. It's either pushed, in that case, we're pushing. This arrow means we're pushing the product from one location to the next location. Or it's pulled. Pulling is like that. For each process, we need to go and have a look what happens at this process. For example, in this process produces 3 parts at one time. We have something called the cycle time. When it starts to production, how long it will take. We have something called, so we have here cycle time. We have something called change over time. What's change over time? It's set up from other products, other family, and then we stop the machine, we do the setup and change to another product. That's called change over time. So for each process, we have some data about the process, including the production time, how long does it take to produce the product, how much to get the machine ready. We have something called uptime. For example, if you work 100 hours, how many hours do you expect that this machine will be working or this process will be working? That's called uptime. And we have something called the scrap, the percentage of scrap. How many parts will go bad as a percentage for this machine? Now, the third part of the value stream map is something called time frame or timeline. So we have here a process with information. As we see, information is coming from the customer to the supplier, and then we do the production here, and we translate this production into the time taken for each process or storing or anything is divided into either this is a production time, productive time, or value adding time, or a non-value adding time. For example, this lasts for 4 weeks. So we have enough material for 4 weeks. So the parts are idle or doing nothing for 4 weeks. Within these 4 weeks, nothing happened. Then we start this process. How long does this process take? It takes 15 minutes to produce one item, 15 seconds. So here we spent 15 seconds. So imagine that the very last part here has been sitting waiting for 28 days, and then it is processed in 15 seconds. And once again, there is a storage, and then there is 60 minutes of production, and then there is storage, and then 150 minutes of production. This is 10 days here, so 10 days of doing nothing, and then 150 seconds of doing the process. It turned out when you add all the value adding activities and the non-value adding activities, you get two values. One of them is called production time or process time. It's the actual time taken or required to produce the product. For example, we need 18.7 minutes in order to produce the product. However, there is something called process lead time. In this company, they started ordering the product and receiving the product. They started receiving the product, and it took them 57 days until this product has been produced. In other words, you spend your money. It lasted 57 days in production, while during these 57 days, the actual production is 18.7 minutes, and the remaining is actually a waste. And this is pretty much everywhere. And that's the main contribution behind the lean system. Wherever you go, you will find that you're wasting a lot, because not all the time you're consuming is actually a productive time. Most of them are actually wastes. Before we proceed, we need to introduce some of the tools that we use. For the material, whenever there is a process, we use this for a process. This is the name of the process. And inside the name of the process here, how many to be produced per process. And then this is called data box. It's added to this one, It includes things as it takes 45 seconds to produce one product, 30 minutes to change from other products to this product, to do a setup. This machine works 3 shifts and it has a scrap percentage of 2%. This shape represents the customer and or the client or the supplier. This part represents the inventory. And we don't actually rely on the number of the pieces rather than the time. So we need information about the number and we need information to convert these numbers into how many days. If you have a supermarket or a pull system, you pull something from here, and when it's empty, you use Kanban cards to retrieve the product. This is called the supermarket. You can use this one. The shipment is scheduled. This is included or represents the shipment and the schedule of the shipment. This is used when you have a push system. It doesn't have to be an entirely push system. It can be a push process, while this is a pull process. For the information, if there is a manual or paper information, we use a straight line. When it's electronic, we use something like that. When we need a production Kanban, we need to produce the product whenever there is a Kanban card for the production, we use this one. When it is at retrieval or withdrawal Kanban, this is what is used. When you have a schedule, this is what you use. And then we have general icons such as how many operators are required for a machine. We need to go to see something in person. This is a Gemba. If we have something that is wrong, we need to improve it. We can form a Kaizen event. Here is a Kaizen event, and so on. So let's explain how to form a value stream map again. If you're working at a company, it's preferred to use a pencil and sticky notes. It's also preferred to have colored sticky notes. For the process, we will be using the blue. For the inventory, we will be using the yellow. For the production, we will be using pink. For the supplier or the customer, we will be using green sticky notes. We fill each sticky note for each process and simple. We always start with the customer. And when you draw the processes, leave a room between each of them. For example, let's say this is a process. Don't draw the next process here. Leave this empty, and when you know that there is a following process, leave a large space. Why? Because basically, while we're working, we may find that there is an inventory here, so we need to add an inventory. There is a Kanban card here. There is something here. So leave enough room between each process and the followed process. So we start with the customer and supplier's data. For example, here we have a customer. That customer is ordering a family of a demand 18,400 pieces per month. This family consists of 2 products, very similar products. They are called L and R, regardless of the meaning of this one. We're producing 12,000 L, 6,400 R. They are very similar, so we will consider them as similar products. So the total is we need 18,400 pieces per month. And the supplier who's presenting or who's providing the raw material is providing 500 feet coils. It provides a coil. A coil is something like that. It's like aluminum foil, but it's coiled. It's much larger one. So the next step is to draw the inventory triangles and data. As you can see here, when we receive the raw material, what do? We first store them. So we put a store. Then what are the processes? We need to follow the production. We need to follow the raw material. What happens here? We're doing something here. How many workers? One worker. So we're doing stamping. Regardless of the name, this is process number 1. After we finish process number 1, here we're doing process number 2. But we find that we have already product that have finished product number 1 and waiting their turn for product number 2 or process number 2. So this is called inventory. Then for each process, we need to measure how long do you take to produce this product. When you change from another totally different product, from product X to product Y, how long do you take? If you have 100 working hours, how many from the 100 working hours you're expecting this machine to be working? 85 in that case. So we have here all the processes, and for each process all the data of that process, and then followed by how do we move the data from here to here, or how we're storing the data from here to here. Draw in customer and suppliers delivery schedules and methods. We've already have the customer here. We're delivering by a truck, and we'll delivering it daily. That's what's actually happening in our case. So we don't make any assumptions here. We don't think about anything. We're just representing what happens and takes place in the real life. Similar to this one, if you have a look here, the supplier is providing the coils each Tuesday and Thursday. And these coils are stored here for 5 days. They take 5 days to consume an entire file. Put in information flows, internal and external. Now we're focusing on the information. Information starts with the order. How do we receive the order? In that case, we're receiving daily orders. Are we receiving them paperwork, manual, or electronic? From this figure, it's an electronic order. And we receive extra information here. We receive 30 days forecast, 60 days forecast, and 90 days forecast. In our company, and here's the pink color, this is the department responsible for the production planning. And it's using MRP. And they are providing weekly schedules and weekly delivery, a daily delivery schedule. And it distributes the orders to every process. So every process receives their weekly schedule. At the same time, they send a fax weekly. So there is a weekly fax here to get the raw material from the Michigan Steel Company. At the same time, according to that plan, they are giving their forecast to their supplier in order to improve the performance. The final step here, or not the final step, the next step here is how does the material flow between one process and another process? So as I look from here, how does it flow from here to here? Is it going by pushing the product? So this is the push. Or is it going by pulling the product? Pulling the product will be something like that. The next step is we need to transfer everything into time. Everything into time. So from the previous slide, try to have a look at the previous slide. You will find that between process number 1 and process number 2, we have items stored. We have between process number 1 and process number 2, we have 4,600 from L and 2,600 product from R, or vice versa. I don't actually recall. So by this we mean that we have a total of 7,000 items stored. And because we're dealing with time, we want to transfer this 7,000. 7,000 comes from 4,600 plus 2,400. That's a total of, this is 400, not 600. This is the total of 7,000. So we have 7,000 pieces stored. Why do we add them? Why don't we consider them different products? Because it's a value stream map for one family. So this product is a family of this product. In other words, they are very similar. You don't have to do two calculations for them. They are the same. In that case, we need to use the customer order. How many items does the customer order per month? He's ordering 18,400. If you are aware of the quality tools that we have discussed before, I told you about a tool called takt time. Takt time means synchronizing the production according to the demand. So here is the demand, 18,400. And you're producing this in 1 month. And by month, we mean that you'll be working 20 days. In that case, for the company here, the month consists of 20 days. So they need to produce 920 pieces per day. Okay, then how many hours do they work per day? They work 16 hours because they work 2 shifts. It's not actually written in the previous graph, but in the final graph, you will find that this information is mentioned there. So this company that is working 20 days per week, per month, and it's working for 2 shifts per day, 16 hours per day. So they need to produce 920 pieces per day. And because they're working 2 shifts and each shift is 16 hours, that's 8 hours, so they are working a total of 16 hours. So they need to produce 57.5 pieces per hour. So in order to synchronize the production according to the demand, this demand requires us to produce 57.5 pieces per hour. So far what we're saying that in order to produce 18,400 in 20 days, and each day you're working 2 shifts, you need to produce 57.5 hours per day, pieces per hour. And because you're having raw material equivalent to 7,000 pieces, if you're going to work according to this rate, if you need to produce 57.5 pieces per day, so this 700,000 items will last 121.7 hours. So basically you have 7,000 items and in each hour you need to produce or you need to consume 57.5. So the total is this will going to last 121.7 hours. But this is not the day hours. That's what's called hours of inventory. How long does the inventory work every day? It works for 2 hours, 2 shifts, 8 hours each. So it works for 16 hours. So when we divide 121.7 divided by 16 hours, it turns out to be 7.6 days of inventory. In other words, the 7,000 pieces, when you consume 57.5 per hour, it will last for 121.7 hours. And because you're working just 16 hours per day, this is equivalent to 7.6 working days. So in other words, here, back to this part, this is the part we were talking about. We have 7,000 pounds, 700 items. This is equivalent to a waiting of 7.6 days. This is equivalent to a waste of 7.6 days. Similar to this one, you can compute this one, and you can compute this one, and you can compute this one, and compute this one. And according to the time taken for each process, this is 1 second. This takes 39 seconds. In other words, if you add all the production time here, in order to produce the product, when we don't waste our times, it only takes about 188 seconds. However, the material here stayed at this place for 23.6 days. This is a huge difference. It means from 23.6 days, the value adding activities amount up to 188 seconds, 3 minutes. And the remaining time is waste, totally waste. If you have a look here, this is a huge waste. This is another waste. This is another waste. This is another waste. Another waste. If you have a look here, this is a waste, 85%. It's just working for 85%. The change over time, this takes 1 hour. 1 hour to change from another product to this product. It's a lot of time. How can we improve this one? This one has a uptime 80%. So it's working 80 hours of any 100 hours. So all of these are considered wastes. We can work on improving this one. So here is an important aspect about the lean. Whatever I've taught you so far is not actually used as a solution. It's used to identify where can I find the problem, where's the problem, what's going wrong in my production system. But it doesn't give you a clear hint or a clear way of solving the problem. It's up to you to solve the problem. As I told you so far, this was for the production. Can we make a value stream map for the office? Yes. Office functions support many job floor value streams, such as purchasing and payrolls. We have payroll, we have purchasing. All of these are actually processes that needs value stream map. Moreover, the actual demand or the rate of customer demand is very hard to see. Unlike in the production we know that the demand is 18,400. We don't know how many will be ordering a specific item. And the inventory in the service includes paperwork, baskets, out of basket, voicemail, email. The cycle time or the time of doing the production is not very standard. It's not like the production. When I say it will take 1 second, it's 1 second for the production. In the service, the variation is higher. It may take longer or shorter time. And there is always a confusion about who's the customer and what is the value. What's considered value in the service. But again, we need to eliminate the waste. So what we can do is we need to define boundaries of the value stream map, and there has to be a product or service to follow, such as a purchase order, payroll document, order, customer order, something to follow in order to draw it. So let's have a look at this one here. Instead of having the time between both of them as inventory, what happens is, let's say that you need to send some purchase order from this place to this place. You do some process here, and then you put it in your mail side, in the outbox mail. In other words, in the box where every messages are collected to be sent away, and then it is transported, or it's being in process of moving from one place to another place. So this is called waiting or moving. And then it arrives at that location, but it arrives collectively for all the people. And then we need to retrieve it and send it to the specific person. So instead of saying that we have just one inventory like that, we have now 3 inventories like that. One is outbox, one of inbox, and one is the process or the waiting time in between. So if you have a look at this one here, I mean this one here, here's the customer. The customer is sending a mail order, and sometimes there is some phone clarification. And these are collected here in the voice box or email box. We don't open the mail every minute. We open it every 3, 4, 5 hours. So here it waits for 5 hours. And then when we decide that this is an important email, we collect the important emails together, and we do a meeting to analyze whether this is what we need to process or not. So we need to we need to do some arrangement that will take around 3 extra hours. So far from receiving this email, it may take up to 5 hours, and 3 hours, 8 hours. And then somebody will receive the order. So order receive or order receipt, it takes 10 minutes. So in other words, we can construct a service value stream map. However, as you see here, every process of every waiting is divided into several waiting. For the case that we see here, the total production time, the cycle time or the production time was 8 hours. However, the total process lead time is 10 days. It takes 10 days to process this one. However, in these 8 days, in 10 days, we need only 8 hours to do the business. Thank you for listening.